Chapter 6, Lesson 7 of Geometry, and we want to wrap up this chapter by looking at planning coordinate proofs. Most of this lesson will be, as far as homework goes, will be filling in the blanks. Maybe a few problems where we'll actually calculate using coordinates, and we'll take a look at one example possibly when we do that. The key to doing coordinate proofs, and there's three keys to doing coordinates proofs. The first key to being able to do a coordinate proof is being able to place the figure in the coordinate plane, and we talked about that in Chapter 6, Lesson 6. Remember, we either want the vertex at the origin or we want to center the figure around the origin, and then we want to use multiples of 2 for the variable coordinates. So just a quick review: if we had a square, we could either center it on the origin like this. The other option, again, probably easier if we're dealing with a square, would be to place a figure where the origin here is one of the vertices, and then just use multiples of 2 going this way. That way zeros are involved, and it makes it a little bit easier to calculate. But again, we do the same thing where we place it, we define the coordinates using multiples of 2, and then those formulas that we're going to use are a little bit easier to deal with mathematically. The second key to using or doing coordinate proofs is to make sure that we remember the formulas and then be careful to choose which one we need. Again, if we want to use slope formula, we want to use that if we need to show that sides are parallel or sides are perpendicular. If we want to determine the midpoint, we would use that in case we wanted to show that two segments or a segment was being bisected, because then the midpoint calculation would be the same for both. If I want to show that lengths are equal, then I would use the distance formula. So the key to proofs in this respect is to know these different formulas, not only know what they are, but then also know what the use of them are, or know what the use of each one is. It's like having a toolbox. If you're going to have a tool in your toolbox, you need to know what the tool is used for, as well as how to use it and when to use it. It doesn't do any good to have something in your toolbox if you don't know when or where or how to use it. So it's important to know what these formulas are and then when you're going to use them, depending upon what you're trying to prove. And then last thing you need to do is you need to be able to think about or plan and determine what is going to be proved. What do I need? Do I need to show the lengths are equal? Do I need to show the sides are parallel? Do I need to show that the length's been bisected? What am I trying to show, and what am I trying to prove? And once you've established that, then you can decide which tool to use, which formula to use, and then you can go ahead and place the figure, assign the coordinates, and then do what you needed to do. Now, some of the answers I have listed here in A, B, C, and D, and you're going to just need to read through the proof and then fill in the blanks. The diagonals of a parallelogram bisect each other. That was a theorem that we have, so we want to prove that. So the parallelogram ABCD, that's what we're given, and we want to prove that AC, which is this length from here to here, bisects BD, and that BD bisects AC. So here's the plan. You need to fill in the blanks. Place the parallelogram in the coordinate plane with a vertex at the, where do we place a vertex? At the origin. So answer for A would be origin. And a side along one side is along the what? The x-axis. So that would be for answer B. Since the midpoints will be involved, we're going to use multiples of 2. We want to use multiples of 2 whenever we have the midpoint formula to name the coordinates. Then to show the segments bisect each other, we need to show that the midpoints have the same coordinate. If they bisect each other, then the midpoints should have the same coordinates. So again, all you're going to need to do is to fill in the blank. Let's do one more example and then we'll wrap this up. So here we have the name, or the median to the hypotenuse of a right triangle is half the hypotenuse. So when we draw a median, this length OP, we want to show that it's half the length of this hypotenuse. Triangle MNO is a right triangle with right angle MON, so this is the right angle. P is the midpoint, so we want to prove that OP is 1/2 of mn. So here's the plan. We'll need to fill in the blank. Place the right triangle in the coordinate plane with the vertex of the triangle, that's the answer to letter A, at the origin, and the blank along each axis. So each leg along each axis, that's the answer to B, would be leg. Since the midpoints will be involved, we want to use multiples of 2, that's the answer to C, to name the coordinates for points N and for points M. So those will be the answers to D and E. So we'll use the blank formula to find the coordinates of P. Well, P is the midpoint, so we're going to use the midpoint formula to find the coordinates of P. And then to compare the lengths, we'll need to use the distance formula. So we would use the distance formula to find MP, and the distance formula to find OP, and the distance formula to find PN, whichever lengths we needed to use in order to prove that. Now, we would need to prove that OP is half of MN, so we would need to find MN, the entire length, and we'd have to use OP and show that those are half. Okay, so again, the majority of your homework will be filling in the blanks of these plans, and we need to, again, the point is to try to understand what formulas we'll need, how to place the figure in the plane.